In this video, we will take a look at the vertex form of quadratic functions. First of all, let's consider this function 2 times x minus 1 squared plus 3. This function is a quadratic function because it is a polynomial of degree 2. From this function, we should know that for any input value x, this part 2 times x minus 1 squared should be greater than or equal to 0. We can conclude this because any number after squaring will not be negative. That means now we should know that fx is actually 3 plus something which is non-negative, that means positive or 0. In other words, fx cannot be smaller than 3, or we should say that fx is at least 3. Therefore, we can conclude that 3 is the minimum value of fx. This output value fx is equal to 3 when the value inside the square bracket is equal to 0. That means when the input value x is equal to 1, then the output value fx will be equal to 3. From this result, we can conclude that for the graph of y equals fx, the minimum value of y is 3, the equation of the axis of symmetry is x equals 1, and the coordinates of the vertex are 1 and 3. Now let's consider another similar example. Suppose now the function is minus 3 times x plus 2 squared plus 5. Again, this time we can find the vertex by considering for any input value of x, this part minus 3 times x plus 2 squared has to be smaller than or equal to 0. We can have this result because x plus 2 squared is always positive or 0, it cannot be negative, and when this number x plus 2 squared is multiplied by minus 3, the whole thing has to be non-positive, that means it can either be negative or 0. That means in this case, fx is equal to 5 plus something negative or 0. In other words, fx in this case cannot be greater than 5. That means 5 is the maximum value of fx. Fx is equal to the maximum value 5 when the value inside the square bracket is equal to 0. That means when x is equal to minus 2. As a result, we can conclude that for the graph of y equals fx, this time the maximum value of y is 5, the equation of the axis of symmetry is x equals minus 2, and the coordinates of the vertex are minus 2 and 5. From these two examples, we can see that when a quadratic function is expressed in the form of a times x minus h squared plus k, we can quickly tell that the vertex of the graph should be hk. Therefore, this form of quadratic equation is called the vertex form because we can quickly tell what the vertex is. When a quadratic function is expressed in the vertex form y equals a times x minus h squared plus k, then the vertex of this function is given by hk. When I change the value of h, then the graph will be shifted to the right or to the left. On the other hand, when I change the values of k, then the graph will be shifted upward or downward. The equation of the axis of symmetry is x equals h. That means when I change the value of h to 1.8 like this, now the equation becomes x minus 1.8 squared plus 1.3. And now the equation of the axis of symmetry is x equals 1.8. Now when I change the value of a, the vertex will remain unchanged, but the shape of the graph will be changed. This value of a is same as the one in the general form. That means when the value of a is larger, the graph will be narrower. And when a is negative, the graph will open downward, and in this case, the graph has a maximum value. And when a is positive, the graph opens upward, and now the function has a minimum value. To conclude, when a quadratic function is expressed in the vertex form a times x minus h squared plus k, we can quickly tell what the vertex is. The vertex is always hk, and the equation of the axis of symmetry is always x equals h. When a is positive, the curve will open upward, and in this case it has a minimum value. On the other hand, when a is negative, the curve will open downward, and in this case it will have a maximum value. And the minimum or the maximum value of a quadratic function is always given by k.